So in this section, we are going to be looking at right triangles. And then in the remaining, there we go. In the remaining sections of Chapter 9, we're going to be looking at what if it's not a right triangle? What if it is not a right triangle? What are we going to do? So a few of the things that we need to refresh are the fact, just basics, literally. If I've got a right triangle, there's my right angle, so this is the hypotenuse. Okay, these two angles together will add up to 90, because 90 plus these two will be 180. And then this is a leg, and this is a leg. Another thing that we also need to look at is what's called bearings. So we use bearings when we are flying airplanes and when we are floating boats. So a bearing is going to be from a point of origin, okay, which is going to be at the origin. Okay, and we'll have whatever the point of origin. So if I'm taking a bearing from somewhere, it's going to be from here. The first thing that you'll notice is it's either going to say north or south. So from this point, I need to start either up at the north axis or down at the south axis. Okay, and then it's going to tell you to swing out one direction or the other. It's either going to tell you to swing east or west. So this side is east, this side is west. So for instance, if I have something that says north 57 degrees west, what that means is I start north, but then I swing 57 degrees to the west. So from there, this will be 57 degrees, which means this will be 33 degrees. Okay, so you can find different measures that way. Same thing, let's do another example. If I've got south 31 degrees east, that means I'm starting from the south and I swing out 30 degrees towards the east, or 31 degrees, because that's what I said. Okay, so that is 31 degrees, which means because these are right angles, you would know that this is going to be 59 degrees. Okay, so you've got different ways of finding angles by using bearings. But again, the first one will tell you to either start on the north side or to start on the south side. Then it tells you how many degrees to swing out, and then you swing either west or you swing east, just depending on which direction. So knowing that, we're just going to solve some triangles and then look at some bearings. Okay, another thing about bearings is it tells you the direction. Okay, so if you've heard the term getting your bearings, you're finding a direction. Okay, so bearings and directions, same thing. So what I have is a right triangle, and I look at this lovely little right triangle, and I see that I'm trying to solve for angle A, and I know that this is given as 25, and this is given at 15. So what we want to refresh our memory about is, first of all, I can find angle measures using inverse trigonometric functions. And I can also find all of my 6 trig functions if I know the ratios. So using Pythagorean Theorem, this is going to be 15 squared plus y squared is 25 squared. So I'll get y squared is 625. Minus 225 is 400, which means y must be 20. So I'll find out that that's 20. Well, now, just for refreshers, let's say I want to know the tangent of A. Tangent is going to be opposite, which is 20, over adjacent, which is 15. So I get 20 over 15, which reduces to 4/3. So that is 4/3. Well, what happens if I want to know what the sine of A is? Okay, so let's do the sine of A. Sine of A is opposite over hypotenuse. So I get 20 over 25, which is 4/5. Well, I thought, hang on, back up. I don't care what I thought. A similar triangle would be what happens if you divide all 3 of these sides by 5. So if I divide this by 5, this by 5, this by 5, I'll get a 5, 4, 3. So notice what the tangent of alpha is. It's 4/3. Notice what the sine of alpha, or A is, sorry. it's 4/5. So just reiterating that all of these ratios stay the same, your angle measure will be the same. Your ratios will reduce to be the same because these are similar triangles. Okay, so let's find another one. I have, and always draw triangles, by the way. So traditionally, and I should tell you this, this is going to be how we remember what our angle measures are and what our sides are. So notice that if I'm talking about angles, they are capital letters. And notice if I'm talking about sides, they're lowercase letters. And the corresponding side to big angle A is going to be the side created opposite of that angle, and it will be a lowercase a. So your big A, which is for an angle, corresponds to your little a, which is for a side. Big B and little b, big C and little c. So when I'm looking at this, if B is 2, so B is going to be 2, and A is unknown, and big B is 39. Okay, I want to finish out this triangle. So I want to know what the A's are. I want to know what the B's are. And I want to know what the C's are. So I know that little b is 2. I know that big B is 39. And I know that I can figure out what the remaining parts of this triangle are. So first of all, C is 90. Okay, that's given. And I know that A must be 51 because 51 and 39 makes 90. And 90 plus 90 is 180, which is all of the angles in your triangle. So now what do I need to know? Well, I can use trig functions to find out a remaining side and then either go to Pythagorean Theorem or use trig ratios to find the other side. So what do I know? I know that the sine of 39 is 2 over c. Okay, so the sine of 39 equals 2 over c. So the sine is opposite over hypotenuse. So now I'm going to multiply both sides by c. And then I'm going to divide both sides by the sine of 39. So also notice that this is actually 1 over sine is the same thing as cosecant. So I multiplied both sides by c. So it reduced on the right, and then I divided both sides by the sine of 39, so it appeared in the denominator on the right. And so that is my answer. So grabbing my calculator, making sure that you're in degrees, you will have 2 divided by the sine of 39 gives me 3.18. 3.18. So I now know that C is 3.18, and that is little c. Okay, so you've got a completed ratio at this point. So I know that this is done and this is done. What does she mean by completed ratios? The angle measure and its corresponding side. Angle measure, corresponding side. So I need a corresponding side. I can either set this up and say, well, tangent is opposite over adjacent. So I could say the tangent of 39 is 2 over a. And then I'm going to multiply both sides by a. So I got a tangent 39 is 2. And then I'm going to divide both sides by the tangent of 39. So I get 2 divided by the tangent of 39, or 2 times the cotangent of 39. Okay, so if I do that, 2 divided by the divided by the tangent of 39, that would have been catastrophic. 39 gives me 2.47. So I find out that A is 2.47. So I've got 2.47 here. Well, I could have also used Pythagorean Theorem. So I've got A squared plus B squared equals C squared. So I was looking for this. So A squared plus 4 is, why did I not write a plus? plus 4 because b is 2. So b squared, and then c squared would be 3.18 squared, gives me 10, 11, 24. So I'm going to subtract 4 from both sides. So that's going to give me a squared equals 6.1124. And then take a square root, and I will find out. So minus 4, and then raise that to the 0.5 power, and I get 2.47. Now notice it's slightly different. There's a rounding error there. And so that's why we're taking it to a specific decimal place. Sorry. We're taking it to a specific decimal place because this rounds to 2.47 and this rounds to 2.47. So either way, I get 2.7 and I have a completed triangle. All 3 angles, all 3 sides. So let's do another one. We have, I'm going to find A, I'm going to find B, and I'm going to find C. So I've got little a is 6, I've got big B is 53, and I'm also told that this is a 90-degree triangle or a right triangle. So when I draw this, there's my right angle. I'm going to look for little c. I know that B is going to be 53, and I'm looking for little b, and I'm also looking for little a. Well, I can figure out what big A is. So this is going to be 37. And so now I just have sides remaining that I need to solve. So little a is 6. So what can I find using this angle? I know that the sine of 53 is going to be b over 6. That's a lie. The tangent of 53 is going to be b over 6. So the tangent of 53 is b over 6. Opposite over adjacent. So multiply both sides by 6. And I get 6 times the tangent of 53 is b. Divide both sides by tangent. What did I just find? I don't even need to do that. My brain is not here yet, sorry. I know what b is. I don't have to divide anything. So 6 times the tangent of 53. 6 tangent 53 is 7.96. So I find out that b is 7.96. And now again, this is a right triangle. So I can either use Pythagorean Theorem to find out what c is, or let's just practice some trig functions. So now I'm going to say that I've got adjacent over hypotenuse. So notice I'm using the unrounded value. Okay, so I'm going to find the cosine of 53 is adjacent over hypotenuse. So I'm going to multiply both sides by c. So c times the cosine of 53 is 6. Then divide both sides by cosine. And I get c equals 6 divided by the cosine of 53, which is the same thing as 6 times secant of 53. So 6 divided by the cosine of 53 gives me 9.97. So I find out that c is 9.97. Well, what happens if we use Pythagorean Theorem just for practice? That means I've got a squared plus b squared is c squared. There's no reason I chose to solve for b first. I just did. I could have solved for c first. So if I've got my a is 36, I'm sorry, a squared is 36, plus b squared is going to be 7.96 squared will equal c squared. So 36 plus 7.96 squared gives me 99, 36, 16. So 99, 36, 16 is c squared. And now take a square root of that. So I'm going to raise it to the 0.5 power, and I get 9.97. So 9.97 is c. So again, you get your answer either way. just find trig functions, trig ratios that work with what you have.